Hi, and welcome my fellow data explorers to another interesting chapter in business analytics course. We are going to talk about the main essentials of statistics, samples, types of sampling, and confidence intervals, right? So let's say you want to study cheese consumption in the US. You need this because you work as a consultant to a Dutch cheese marketer who now wants to enter the US market, set up a business there, and understand how big is this new market for him, right? So you cannot probably go and ask every household how much cheese they consumed last week or last month, right? You could ask only a few hundred or few thousand households the same question and any other demographic questions you would want to ask, right? Now, hold on, you will say we do a survey every 10 years, which is population census survey, but census survey is not done about categories like cheese and so on, right? It's done about individuals, their education, and other employment details and so on, right? So you need to do a custom survey, and this can't be about every household in the US market, right? So this is about using samples to infer about population, which is the whole US market, all the households in US, right? But this can't be done very arbitrarily, right? You cannot just choose your neighborhood neighbors and say their cheese eating habits are all of America's cheese consumption habits, right? You cannot just sample households either from very richer or poorer neighborhoods alone in your city, right? You will have to use many households that together represent the US market. So it could be urban versus rural households, affluent versus less affluent households, households of different ethnicities, to clearly reflect the whole of US market, right? And this is where what we call as stratified samplings are used to represent the whole US markets, where households are sampled from various strata in the society. And this is to ensure our sample is very representative and unbiased practically. Another way to ensure that there is correct sampling, and that is to take a very large sample, probably some 200,000 households, using what is called as random sampling. Now, what's random sampling? It's like playing the game of chance with your data, right? Randomly selecting samples is like spinning a roulette wheel. Instead of winning money, you get households here where you are going to ask the survey questions. So how it would be done? It's like indexing all the households in US from 1 to 129 million and then selecting one number from this range, right, without repeating this number, and doing the same thing for 200,000 times. And that's the way to build a sample of 200,000 households, right? And when you have such a large random sample, you can be assured that your inference would be good enough, right? As soon as we say now we are going to infer from samples for the population, we realize we cannot get an exact count of cheese packets consumed per month, right? Or exact pounds of cheese every household consumes per month, right? There will be uncertainty about what is the actual consumption because we have to practically work with samples. So we have what we call as an estimate. It's an approximate number for an actual value when working with samples. How do we quantify uncertainty with these estimates, right? One way is to provide standard deviations around the average consumption value, right? Another way is to write this probabilistically. What is the chance that on an average a consumer ate, let's say, 3 pounds of cheese every month? Put another way, what is the range of monthly cheese consumption value in pounds that an average US consumer had, and we could say that range with, let's say, 95% confidence in it. Put it another way, let's say we did a survey 100 times, what range of cheese in pounds, your estimate will fall at least 95 times in this sampling exercise, right? And this is what we call as confidence intervals. Confidence interval typically gives you a range of values possible for a statistical estimate. Now this range is where you could be 95% or 90% confident that a number will lie, right? So for this cheese consumption example, your confidence interval would be say 30 to 45 pounds, and we don't report a single number that cheese consumption is 40 pounds a year, but instead we say we are 95% confident that annual cheese consumption actually lies between 30 and 45 pounds range, right? So this reporting this range is about providing confidence intervals with an upper bound and a lower bound, right? So these were the three key concepts we studied. What are samples? What do they achieve for us? How to go about sampling? We said two ways of sampling, one stratified sampling, another random sampling. And when we have samples, our inference is only an estimate. It can't be a perfect exact value. You have to therefore say what is the confidence in your estimate, what is the confidence intervals for a range or a range of values for your estimate, right, that you would be, let's say, 90 or 95% confident about, right? So these are key concepts in any statistical analysis, and they would be applied when we do statistical comparisons, right? So here on we go and talk about what are statistical comparisons, an essential tool in descriptive analytics. Okay, stay tuned and see you in the next lecture. Thank you.